Alright guys, this video is about accuracy and precision, and then how to calculate percent error. Okay, what is accuracy? Accuracy is a measure of how close a measurement comes to the actual or true value of whatever is measured. Think of a bow and arrow, shooting arrows at a target, trying to get to the center bullseye. Okay, how close you are to that bullseye. Now that numbers can come into play as well. Okay, how close you can be to that certain number. Then there's also another term called precision. Precision is a measure of how close a series of measurements are to one another, irrespective of the actual value. So if you have a bow and arrow, you shoot the arrows at the target, and they're kind of far away from the bullseye, but they're off to the right, but they are all very close together. They have a good grouping or precision. Okay, precision is completely different from accuracy. And we need to realize that going forward. Okay. So here we have a couple different groupings, okay, but this is using darts. We can see that this first dartboard here, the darts went into the bullseye, which tells us we have good accuracy and good precision. Good accuracy is how close you are to the bullseye, and precision how close they are to each other. The next bullseye, you can see that they're completely off the this target, they're completely off the bullseye. They're up a little bit, but they're close to each other. So that means it has good precision, poor accuracy. And then you have a neither. They're not near the target, nor are they close to each other. Okay, now let's look at some numeric values. So determine the accuracy and precision of the given measurements. So 100.00 grams is our target. Okay, and we have a little bit of an error. So what that means is our window is from 99.8 to 100.2. There's our window. There's our target goal. So we have three sets of numbers, A, B, and C. Now our first measurements are very close to the target, okay? And they are very close to each other. So A is both accurate and precise. Letter B, these measurements here are not close to the target. They're out of the range, but they are close to each other, which means they are precise. And letter C, they are not anywhere close to the target, or are they close to each other? So C is neither. Okay. Okay, let's look at error and percent error calculation. Now, there's a value called the accepted value. The accepted value is the correct value for the measure based on a reliable reference or unreliable references. It is going to be from a data table or a chart. Okay. Then we have an experimental value. As it says in its name, the value measured in the lab. This is going to be your calculated results from lab or class. Now, to calculate something called error, error is the absolute value, that's what these brackets are, absolute value of the experimental value minus the accepted value. Percent error of a measurement is the absolute value of the error divided by the accepted value multiplied by 100. So in our formula, we're going to see EXP and ACC. EXP is an abbreviated version for experimental value, like your results from lab, and ACC is the accepted value, your known results from a table or chart. Okay, so here you go. Percent error equals your absolute value of your experimental minus your accepted, and that numerator is your error divided by your accepted value times 100. So it's very straightforward. It's not supposed to be a hard formula, just that in the numerator you must take the absolute value. Okay guys, just make sure you keep this percent error formula handy for laboratory results.